So what are the ecological consequences? Does it matter if the pH changes a little bit? Well, biggest consequence is the appearance of corrosive surface waters, undersaturated and key carbonate minerals necessary to produce calcareous material. Well, so what? Okay. So first of all, you need to understand that there are critical carbonate minerals. And the first one to be depleted is aragonite. So you need a suite of different minerals to form skeleton material, calcareous material. But if one is not available, the entire production collapses. Okay, but what are we talking about? Well, we're talking about calcifying organisms in the ocean that include mollusks, coccolithophores, crustaceans, and stuff like that. Corals, okay? But there are key ones. I mean, corals are very important, as you know. But these guys here, the coccolithophores, they are extremely important. They are sort of the start of the food chain. It's a plankton. It's a plankton that dominates the world oceans. And that's sort of, that is it's an important component of the marine food pipe. And you learned about marine food. So where will this undersaturation happen and when? Okay, so large-scale undersaturation and key carbonate minerals will develop first in the surface waters of the Southern Ocean and the Arctic Ocean well before the end of the century. And here's one prediction for the Southern Ocean, and the colors give you the timing. Okay, when the surface waters become undersaturated. And you can see in terms of the timing, it's sort of mid of the century. Okay, it's within your own lifetime where you will experience this significant shift. And in large areas of the Southern Ocean, shown here in this. And it's a significant switch. It's like a switch which makes it impossible for these calcifying organisms to form. Okay, and there will be a transition phase where it will be significantly hindered the production, but this transition phase is only a few years. Okay, so the adjustment of the marine food web does, it's within only a few years, and it is that's the big question. How can the ecosystem adjust to that missing component? Okay, on the next slide, which is the final slide of this presentation, okay, there will be a thank you at the end. But anyway, I want to show you also in the map of the entire ocean in terms of aragonite saturation state. Okay, some colors here, but the key thing is that the dark red are the regions where the transition to corrosive environments will happen first. And you can see the Southern Ocean here, Southern Ocean, big part, but also large parts in the North Atlantic, North Pacific, Arctic Ocean. Okay, where this transition will happen. Arctic Ocean here, effects are due to the disappearance of the ice cover. You all of a sudden have that RC exchange, which is limited in the presence of ice. Okay, floating sea ice I'm talking about. All right, so thank you very much for watching this rather long tutorial, but I hope that you learned about ocean acidification, what it is, what are the consequences, where, when, and stuff like that. Okay, all right, thanks for watching.